Hello, my name is Tommy, and today we're learning about empirical formula. So the empirical formula for a substance is the ratio of atoms in a compound. So you may have a substance Cl2O2, but the empirical formula would be ClO because the ratio of the atoms to each other is 1 to 1. There's one Cl for every oxygen. So in order to find empirical formula, we need to know the mass percentage, and we do. So when you're given mass percentage, what you do is that you take your 94.1% and you turn it into grams. And we can do that just by assuming that there's a 100-gram sample. And if you have the complete 100%, then you have the 100 grams. So the 94.1% becomes 94.1 grams, and the 5.9% is 5.9 grams. Then we can multiply by the molar mass of each one. So 94.1% is oxygen. So we use the molar mass of oxygen, which is 16 grams. So we multiply by 1 mole for 16 grams oxygen. And then we multiply by the molar mass of hydrogen, which is 1 mole per 1 gram. And we get ourselves 5.88 moles of oxygen and 5.9 moles hydrogen. So now that we have the moles of each one, we're going to divide by the lowest number that we have here. And in this case, it's 5.88. And that gives us 1 oxygen, if we divide by 5.88, and 1.003 hydrogen. So in this case, if you have something like 1 and 1.003, you can just round to 1 because it's close enough. And if you do that, we get an empirical formula of OH or HO. So that would mean our answer is A. Whenever you have a question that talks about a combustion reaction, usually it is carbon analysis in terms of finding empirical formula. So in this problem, a sample is burned in excess oxygen and results in 33.0 grams CO2, 13.5 grams H2O, and some NO2. So now we have to find the empirical formula of the substance. So the way we do this is first, we take both 33 and 13.5 and use the molar mass of CO2 and H2O to figure out the moles of CO2 and H2O. So if we multiply by 1 mole CO2 per 44 grams and 1 mole H2O per 18 grams, we get 0.75 mole CO2 and 0.75 mole H2O. We're going to use molar ratio to get the moles of hydrogen and carbon in each substance. So for every mole of CO2, there's only one carbon. So we do 1 mole carbon. So 1. So it's 0.75 mole CO2 times 1. And that gives us 0.75 mole carbon. For water, it's the same thing, except for every mole of H2O, we have 2 hydrogens. So we end up with 1.5 mole hydrogen. So now that we know that, it's our standard empirical formula problem. We can divide by our lesser one, which is 0.75 for both. And we can get 1 carbon per 2 hydrogens. So now that we know this, we know that it's CH2, but there's one thing that people might really forget pretty easily, and that is the question mentioned that there was some NO2. So that means that we have some nitrogen in our formula. So all we do is just add 1N, and that is our answer.